Hi guys! In this video, we are going to be looking at average rate of change. This is a topic that you have covered briefly in Algebra 1, and we are going to re-look at in different ways today. Whether you can believe it or not, this is our last topic that we are going to be doing this school year, which is crazy, which means this is the last video I'm going to be recording. Hopefully, we will be able to learn in the classroom in the fall. I look forward to that. So this page here is going to go over the concept, and then we're going to do some notes, and then we're going to do a couple of examples. So example 1, suppose you start a car trip at 12 o'clock p.m. and record the distance that you traveled every few minutes. The distance, f of x, you traveled is a function of time x. So here is our time, 1, 2, 3, 4, 5 hours, and then you have your distance here. So you can see after 1 hour, you've traveled 50 miles. After 4 hours, you've traveled 200 miles. So we are going to look at different aspects of this and examine the average rate of change. So it says, use the graph to estimate the total distance traveled from point A to point B. So if I look at point A is 50 miles traveled. Point B is at 200 miles. So the difference between those would tell us the total distance traveled between those 2 points. So I would do 200 minus 50, and I'd get 150 miles traveled. So from point A to point B, 150 miles traveled. Next it says, calculate the average speed traveled by the car from point A to point B. So we travel 150 miles, and from point A to point B, you have 3 hours. So from point A to point B, point A is at 1 hour. Point B is at 4 hours. So that's 3 total hours there. So since we traveled a total of 150 miles in 3 hours, and distance equals, not distance, sorry. Rate equals distance over time. So the distance is 150 miles over 3 hours. Think miles per hour. For speed limit, that's where I'm coming up with distance over time. So if I actually do that out, I get 50 miles per hour. And that is called my average speed traveled. So when you're thinking about average rate of change, notice we go a little bit slower in the beginning, and then you go a little bit faster here. So from here to here, you're covering more distance in 1 hour than you covered from here to here. So when you're talking about the average speed, you're talking about the speed that connects these lines, or the slope that connects those 2 points, sorry. So at the bottom here it says, so this was done from a graph. I looked at 2 points on a graph, I found the appropriate numbers that go with them, and I went from there. At the bottom it says use the table to calculate the average speed from 2 to 3. So I'm looking at these. So again, it's distance over time, and the distance, 300 or 130 minus 90 is 40 miles. And the time, 3 minus 2, is 1 hour. So this puts together for distance over time is 40 miles per hour. So now for a little bit of note taking. So you will remember the rate of change of a function y equals f of x between x equals a and x equals b is the change in y, which you might remember as this, over the change in x. So the change in y is f of b minus f of a, and the change of x is b minus a. So that's exactly what I did on the last page. The last one distance minus the other distance is the change in distance. One time minus the other time is the change in time. So the average rate of change is the slope of the line between 2 points. So this is like your slope. So remember y2 minus y1, that's like f of b minus f of a over x2 minus x1, x b minus a. So now we're going to look at a couple of different ideas of how to use this. So when it says find the average rate of change on the following intervals. So I have this function here. So there are different ways to state this. So if I'm looking at a function and I have the x values, x equals 1 and x equals 3, I need to know what y values go with that so I can have actual points. So here's the x value, here's the function. So 2 times 1 minus 5 is 2 minus 5 is negative 3. So this point is 1 comma negative 3. Then at x equals 3, I've got 2 times 3 minus 5, so that's 6 minus 5, that's 1. So this point is 3 comma 1. So when you're looking for average rate of change, you need to find the 2 points, and then essentially you're just finding slope between them. So I'm going to do 1 minus negative 3 over 3 minus 1. Remember, order is important, that you stay with the same order. Whatever you do on the top, you do the same order on the bottom. So that's going to be 4 over 2, which is 2. So that is my average rate of change on the interval from 1 to 3. So this specifically gave us x equals 1 and x equals 3. Down here, 4 and 7, with these brackets around them, this is called interval notation. So what this means is x equals 4, and this one is x equals 7. So you're doing the same thing, you're just giving it in a different way. So if I have x equals 4, same function, 2 times 4 minus 5, that's 8 minus 5 is 3. So that point is 4 comma 3. 5x equals 7, 2 times 7 minus 5, 14 minus 5, so that gives me 9. So I've got 7 comma 9. Now over on the right here, you see a table. If you prefer to show that in a table, so you have 4 and then you have 7 as x's, and then you have 3 for the y that goes with 4 and 9 for the y that goes with 7, this is a visual that might be helpful to you to make a table given the x values. So once I have those 2 points, now I can do 9 minus 3, so y minus y, or f of a minus f of b minus f of a, over 7 minus 4. So that's going to give me 6 over 3, which is 2. So you notice that on both intervals, the average rate of change is the same. So now I'm going to look at one more example. I've looked at a table now. I've looked at given an equation. When you're given an equation, you need to plug in the x values to find the points. And now I'm going to look at given a graph. So here I'm given a graph. I do have the equation, but I don't necessarily need to use it. I'm looking for the interval from 1 to 3. So from 1 to 3, what I do is I find the points where x equals 1 and x equals 3. So at x equals 1, I look up to the line and I see the point 1 comma 4. Where x equals 3, 1, 2, 3, I see the point 3, comma 0. Now I can find slope or the average rate of change using the formula, or I can do it using the graph. So if I use the formula, I'd have 0 minus 4 over 3 minus 1. So that would give me negative 4 over 2, which gives me negative 2. Another way you could do that is to count out like the triangle like you guys usually do finding slope, and you would get negative 4 over 2. So now for part B, again, this one was given x equals 1, x equals 3. This is given in interval notation, but what it means is x equals 2 and x equals 7. So at 2, I have the point 2, comma 1. At 7, here's 7, and I look up and I see 7, comma 15 or 16. So now from here, I find the average rate of change. So I've got 16 minus 1 over 7 minus 2. And I have 15 over 5, which is 3. So here's what's important to recognize on this graph. Your average rate of change, notice here, it went down before it went up, but all your average rate of change is doing is seeing the straight difference between those 2 points. It's on average what's happening between those 2 points. So in this one, you're only going down, and that one's pretty accurate to what the line is doing. One more thing you want to keep into account is if I had done the average rate of change from like 1 to 5, while the graph is changing between there, because those have the same y values, it actually would end up being straight across. So it would be an average rate of change of 0. So your average rate of change won't necessarily what tells you what goes on between those 2 points, but it'll tell you the general change that happens between the 2 points. And that's essentially what average does.